Hey everybody, hope you're doing well. This video is the start of week 7 here in the 4th marking period. We are moving into our final unit for the entire school year. This is part of Unit 10, which deals with the topic of rational expressions. We're going to look at 3 different things in this unit: how to simplify a rational expression and talk about what it is, how to multiply rational expressions, and then how to divide them as well. This is going to heavily build off of what you learned in the last chapter, dealing with how to factor things. And you're going to see in this whole little unit that we've got here, you're going to do a lot of factoring and continue to use all of those skills. So, today's lesson here is to understand what a rational expression is and then be able to simplify them. So, a rational expression is basically a fancy looking fraction. If you look at the numerator, you look at the denominator, you've got two polynomials. It's not something like 6 over 7 or 2 over 9. We've got, as you can see here on the screen, more complicated numerators and denominators. What we are looking to do with these is simplify them. So in order to simplify these, we are going to factor them apart as far as we can. What you're going to notice in these problems is that there are common factors when you split them apart that allow you to, in a sense, simplify and divide these down further than what you see. So this is kind of a way that we do a little bit of division, if you will, within the fraction, a little bit of reducing. It's just a more complex way of doing it since we're not dealing with just numbers. We're dealing with variables and these polynomial expressions. So I'm going to go through several examples here. I believe there are 3 slides as part of this video with a bunch of different fractions, a bunch of different rational expressions. We're going to go over all the factoring strategies. So hopefully this will be a good review of all of those as well. So remember, when we go through and try to figure out factoring, what we're going to look at is, can we take out a GCF? That's always the first thing we look for when we're trying to factor things apart. Sometimes you'll have one, sometimes you won't. After you check for that, you're going to go through your different strategies depending on the number of terms. Remember, 2 terms, you have the difference of squares strategy. 3 terms, you have the trinomial trial and error strategy. And if you have 4 terms, that's when we use grouping. You'll see very little, if any, grouping in this particular unit. So we're going to focus mostly on GCFs, difference of squares, and also those trinomials to break apart. So let's take a look here at number 1 and talk about how we go through and break these down. So in each fraction here, I'm going to look at one thing at a time. So I'm going to start with my numerator, 4x minus 12. And what I want to do is figure out, can this factor apart? So the first thing I'm going to take a mental check of is there a GCF? There absolutely is a GCF. I could divide a 4 out of both terms in the top. So when we do factoring and GCFs and all this stuff, again, we only focus on one side of the fraction bar. So again, I'm only worried about the numerator. It's like the denominator is not there for trying to figure out where the GCFs and all that stuff is. So up in the top, I can take a 4 out. If I divide that 4 out, I'm left with x minus 3. That's my top factored. Now I'm going to look at the bottom. First question I'm going to ask myself for the denominators, is there a GCF? Well, all I see is a single variable and a constant. There's nothing I can divide out of both terms, so there is no GCF. It's a binomial, so it's 2 terms. The only thing we can do with 2 terms is difference of squares. This is not square rootable. X is not square rootable, neither is 3. So you will see in some of these problems, you might have an expression that doesn't factor at all, which is sometimes on purpose because some of these problems, as you'll see in this unit, have a lot of different things to factor apart. You won't always have to factor every single expression every single time. And you should have a pretty good idea, based on the last chapter, what looks like something can factor and what shouldn't. So you take a look here. We have 4 times x minus 3 on the top, all over x minus 3 on the bottom. When you factor these apart, if you do this correctly, you will find at least one thing that should cancel out. Now, when you cancel things, you need to make sure that it's an entire expression that can cancel. So you see the x minus 3 in the top and the x minus 3 in the bottom. Since those match up, those will cancel. I can't just cancel the x's or just the negative 3's. Anytime you have a plus or minus sign, that groups it together. Multiplication splits things apart, so that's why I can cancel the x minus 3's like I did. Remember, when you cancel things out of a fraction, that's the way of reducing. So what ends up happening is I have a 4 up top, And since my bottom is canceled out, I'll put a placeholder of a 1. We know 4 over 1 is 4. And that is my simplified rational expression. So again, I factored the numerator, taking out the GCF. Denominator had no way of being factored. We saw there was an expression of x minus 3 in both the top and bottom that canceled out. And then we simplified from there. That's what we're going to be looking at here in all of these problems. How can they factor apart, cancel out what needs to be canceled out, and reduce as far as we can from there. So let's continue that here in example number 2. I have 5x minus 20 over 7x minus 28. So what I'm going to do first is worry about the numerator. What factors out of the numerator? So there is a GCF I can take out. I can take out a 5. When I take out the 5, I am left with x minus 4. Now I'm going to go to the denominator, 7x minus 28. What can I factor out of that? There is a GCF of 7. If I take that out, I'm left with x minus 4. Once I do that, that's about as far as I can go with factoring. Now I'm going to look at what cancels. The top has an x minus 4, and so does the bottom. Those will cancel out. What I'm left with is that 5 out front in the top, the 7 out front in the bottom. 5 over 7 does not simplify any further, so that is my answer, 5 over 7. Number 3, very similar type of problem here. I have 3x plus 14 over 9x plus 42. Let's look at the top. Check for a GCF in the top. Well, nothing divides out in the top because they're not divisible by 3. 14 cannot be divided by 3 without it being a fraction. They both don't have variables, so there is no GCF. I don't see anything that's being squared. There's no difference of squares here because neither term is square rootable. So I'm going to go ahead and leave 3x plus 14 alone. Now I'm going to take a look at 9x plus 42. There is a GCF in 9x plus 42. I can divide a 3 out of both terms. When I divide a 3 out, I'm left with 3x plus 14. Again, remember, when you take out a GCF, sometimes it's not just assuming that it's the front number. In this case, you can't divide a 9 out of both things, but you can at least take a 3 out. So sometimes, again, you will have that front number. It won't always be just that, as you've seen probably in a lot of the problems that we've dealt with. But you can take a 3 out of the bottom there. We see that's broken apart now as far as we can go. So you notice the top and the bottom have a 3x plus 14. Those will cancel out. Up in the top, since everything's gone away, I need a 1 up top. I have a leftover 3 in the bottom. A 1 over 3 obviously doesn't reduce, and that's my final answer. Hopefully what you can see, at least with these first handful of problems here, you focus on one side of the fraction at a time. Use the factoring strategies that you know. It's all the same skills, it's just now you're doing more of it with the goal of finding something that'll cancel out. Theoretically, you could simplify these problems down with nothing canceling out, but that would kind of be pointless. So the problems you'll see from me, at least one thing will cancel every single time you try to break these down. All right, so we've done several now with the GCF. Let's go ahead and use some other strategies here. So if we look at number 4, we've got a couple of trinomials, x squared minus 2x minus 15 over x squared plus 4x plus 3. So if I look in the top, there is no GCF to take out. Nothing's in common with all 3 to divide out. So we're going to focus on the trinomial strategy. Remember, you have a trinomial, multiply to c, add to b. So what multiplies to negative 15 adds to negative 2. The two values that will do that are negative 5 and positive 3. X minus 5 times x plus 3 would be the way that you factor that apart. Same thing at the bottom. There is no GCF, so we're going to go to our trial and error here because it's 3 terms. What multiplies to positive 3 and adds to positive 4? X plus 3 times x plus 1. 3 times 1 is 3, 3 plus 1 is 4. So I've now factored as far as I can. I see an x plus 3 on the top and an x plus 3 on the bottom. Those will cancel out. That leaves me left with x minus 5 over x plus 1. That is my final answer. Now you'll notice just a couple of details here that sometimes trip people up. When I get to this final answer here, if I only have one expression on the top and or the bottom, you can put the parentheses back around it. You don't have to. It doesn't matter to me. The one thing I want you to realize though, again, these expressions that have plus and minus signs, one mistake I do not want you to make is in looking at this going, well, I can cross out the X's. You cannot do that. That is a big, big no-no. Okay, so that's why just erase those there. You cannot cancel out the X's. Whenever you have plus and minus signs, you can't cancel out parts of the expression. It has to be the whole thing or nothing at all. So that's why my final answer is left as is, x minus 5 over x plus 1. That will not simplify any further. All right, let's take a look here. The next slide here, number 5, x minus 1 over x squared minus 1. So let's take a look at the numerator. There is no GCF. It's two terms, but neither, I shouldn't say neither in this case, it doesn't follow the difference of squares pattern because both of them are not square rootable. So the numerator is going to remain x minus 1. The denominator x squared minus 1, no GCF. However, this does meet difference of squares. Why? Because x squared can square root into x and x. 1 square roots to 1 and 1. That means I can break this apart as x plus 1 times x minus 1. Now that I've done that, I see the x minus 1s over top of each other. They cancel. Nothing left up top, so I leave a 1 there as a placeholder. The bottom has x plus 1. And again, since the 1 in the bottom is connected with a plus sign to the x, do not cancel the 1s out. Leave that as is. That is the final answer, and that's as far as you can go. 1 over x plus 1. Alrighty, number 6. Looks like we got a couple of trinomials here. So up top, I got x squared minus 4x minus 45. There is no GCF, so I'm going to bypass that step. And we're going to multiply the c and add to b. So the two numbers that multiply to negative 45 and add to negative 4 are positive 5 and negative 9. Now let's look at the trinomial in the bottom. There is a GCF you can take out, so we're going to take out a GCF first. We can take out a GCF of 3. And if I do that, I'm left with x squared plus 8x minus 20. Now in this case, if I look at this at face value, looks like, well, you said something would cancel. Right now, nothing does. Let's go ahead and take this one step further. If I look at the trinomials, or excuse me, the trinomial that's left over, I still want to try to use my multiply to c, add to b pattern. So the denominator in this case would actually take 2 steps of factoring. It's kind of like the problems we saw at the end of Unit 9. You won't have to really worry about seeing that many of those, if at all, okay? But these do exist, so I'm going to show you here anyway. So the 3 is going to stay out front. We're going to worry about the trinomial that's left over. Again, what multiplies is negative 20 and adds to 8? Positive 10, negative 2. Now, I did say at the top of this here, the ones I'm going to give you to do on your own, something's going to cancel. This would be one of these rare instances where here's a problem where we factored it. I'm not leading you down a bad path here. All these factors that we have here are correct. Problem is, nothing cancels out. So, in that case, I'm going to leave it alone. This would be my final answer with it being broken apart as far as I can. Again, that is possible, but I'm telling you, for what I'm going to have you do on your own for a grade, if you're doing it right, at least one thing will cancel out. But occasionally you do get a problem like this where you had your 2 expressions, yeah, they were factorable, but nothing cancels out. So that does, again, occasionally happen. Okay, these last couple examples here at the bottom. So let's talk about these because these look a little bit different, but we're going to use a lot of the same ideas here that we've talked about in the last 6 problems. If I look at number 7, so I've got a numerator of x minus 2 squared. Now, let's talk about what it means to square something. To square something means to multiply it by itself 2 times. If I have x minus 2 squared, that is the same as having x minus 2 twice. So what I'm going to do, for the sake of maybe seeing if something cancels out, is I'm going to write it out 2 times. And you'll see why here in a minute. Now the bottom is where it looks kind of tricky, because it looks like I kind of factored it, and then I kind of broke it with this minus 10 after it. If you're given something like this, which again, I wouldn't worry too much about, but it's something you might see again as you go into Algebra 2 and you see messier looking problems. It looks like it's half broken apart, half not. What I'm going to do here is I'm actually going to break the problem fully apart here by putting it together by distributing that x. So when I distribute the x in, all of a sudden it's going to look like a normal trinomial rather than this half factored, half not problem. Reason why I want to do that is because it's going to make it easier to properly factor and get the 2 factors that are the result of that expression underneath. So now that I've done that, I'm going to play the whole multiply to c, add to b game. So again, my numerator I can't do anything more with other than the couple of x minus 2's. Denominator, what multiplies to negative 10 and adds to 3? Positive 5 and negative 2. So now I've properly factored everything apart. I can see all my factors. Now, when it comes to canceling, just like in regular fractions, you have to have one-to-one canceling. So I see 2x minus 2's at the top, 1x minus 2 at the bottom. They do not all cancel out. I can only cancel out one of the x minus 2's at the top because there's only one x minus 2 at the bottom. So I'm only going to cancel out one of each, and that'll give me a final answer of x minus 2 over x plus 5. Last problem on this slide here, number 8. We've got a trinomial up at the top. No GCF, so I'm going to go multiply to c, add to b right off the bat. So I want to figure out what multiplies to 40, adds to negative 13. Negative 5 and negative 8 will do the trick. My denominator, once again, looks a lot like number 7. It's kind of broken apart, kind of not. So what I'm going to do is I'm going to put it together to make it look like a normal trinomial. So I'm going to distribute the x in and make this x squared minus 9x plus 8. And now I'm going to factor the trinomial at the bottom apart. So again, my numerator stays the same. X minus 5 times x minus 8. My denominator, multiply to c, add to b. 2 numbers that multiply to 8 and add to negative 9 would be negative 8 and negative 1. We see in top and bottom, x minus 8's cancel. Left with a final solution of x minus 5 over x minus 1. So you can see here we're using basically 3 major factoring strategies. We're using some difference of squares, we're using GCFs, we're using trinomials. Again, things can theoretically be presented a bunch of different ways. Again, since we're doing this virtually here and there's not as much live practice, I'm not going to be giving you tons of the more difficult examples here like 6, 7, and 8, but I do want to show you them just so you can at least see how they would work if they are set up a little bit more in a more complicated manner. But again, what you will typically see are problems like the first 4 or 5 where things will factor apart nicely, you'll get something that will cancel pretty quickly, and life will be good. Last quick little problem here, and again, your classic describe and correct. Reason why I want to do this problem real quick is just to again emphasize a major mistake that I do not want you to make doing this. So it says describe and correct the error and simplifying. So here on the left is my original problem. So this has already been pre-factored, which makes this really easy to look at. So if I look at this here, they canceled out the x minus 5's. Well, that makes sense, leaving you with 2 over x plus 2. But if you look in the next step, they canceled out the 2's. That is a big no-no. So like I talked about a couple of times here in the video, you cannot cancel part of an expression that's being added or subtracted. So just because I have x plus 2 in the bottom, does that mean that cancels with the 2 up at the top? In order for that to cancel, both sides would have to be an x plus 2. So the error, don't cancel the 2's. Not like that. So the fix for that, so at the step where it's 2 over x plus 2, there's nothing more than that you can do at that point. This is your final answer, because the 2's cannot cancel, like I just stated. 2 over x plus 2, as far as that goes, that would be your final answer. So again, just to make a point of emphasis there, if you are given a problem where you've got it's set up similar to this here, where you've got maybe some similar looking numbers or similar looking variables, again, you have to cancel the whole expression. Anything that's being added or subtracted, it's got to be the whole thing canceled, not just a piece of it. So I know this video is a little bit longer than normal here, but again, kind of setting this up here so you can get through the next couple of lessons here, hopefully pretty easily, because they're going to look very similar to what we just did here. We're just going to add a couple of operations into it. That should hopefully not be too bad. So we're going to continue again to use all the factoring skills, keep them fresh. We only have a few more lessons left, including this one here, so make sure, again, you're keeping up with your work. Short graded assignment for you to complete with this. Make sure you complete that, submit that in a timely manner here. Again, we are very close to the end of the year, so make sure you're keeping up with your work. If you're having issues getting stuff in or you need any extra help, as always, send me a message on Schoology, shoot me an email, or stop by my office hours on Zoom. I'll be more than happy to assist you. Otherwise, thanks for watching. Stay safe, stay healthy, and we'll see you next time.